Okay, so last time we were talking about ionic compounds and how ions come together to form an ionic bond. And so looking at an example here, we're trying to write the formula for an ionic compound. And it says that we're starting out with a calcium ion, which has a positive 2 charge, and dihydrogen phosphate, which has a negative 1 charge. So they're asking what is the formula for the compound. So what we would do, we'd have to balance the charges mathematically. And so I basically need to have a +2 charge here. I need to make sure my charges cancel out because they have to add up to 0. So I need 2 dihydrogen phosphate anions in order to balance the positive charge of the calcium. I need a negative 2 charge on the dihydrogen phosphate anion. So the way I would write this out, I need basically 2 polyatomic ions. And when I need 2 polyatomic ions, I have to write parentheses around the polyatomic ion if I need more than one. And I do. In this case, I need 2. Okay, so the formula would be CaH2PO4, and parentheses around the polyatomic ion. And there's 2 there because I need 2 negative 1 charges in order to balance out the positive charge on the calcium. An additional problem here says check your learning, predict the formula for an ionic compound formed between the lithium ion and the peroxide ion. So here it doesn't tell us the charge of lithium, so we have to look that up off the periodic table. So looking up lithium on my periodic table, I notice that it is in group 1. So that means its charge must be positive 1. So going back to our paper here, so lithium must be a positive 1 charge because it's in group 1. And then they also mentioned peroxide. So peroxide is a polyatomic anion. Okay, it has a negative 2 charge. And so here my anion has negative 2 charge, my cation has a positive 1 charge. So I need to balance the charges again. So of course I need 2 positive charges to balance out the 2 negative charges on the oxygen. And so in this case the formula is going to be Li2O2. Okay, so we have an overall charge of +1 times 2, which is positive 2 on the lithium, and O2 has a negative 2 charge for peroxide. And so the answer would be Li2O2. So now we need to talk about molecular compounds, or what sometimes I refer to them as covalent compounds. They are a result when atoms share electrons. Okay, so when we're talking about covalent compounds, the atoms are not ions. Okay, they are atoms that basically are sharing their electrons. So they exist as discrete neutral molecules. Okay, they're formed by a combination of nonmetals. So we need to sort of distinguish that from ionic compound. So we said before that an ionic compound is made up of a metal and a nonmetal. And so molecular compounds are formed between either 2 nonmetals or a nonmetal and a metalloid. So it's very important to be able to distinguish between ionic compounds and molecular compounds because we know that there are different rules for naming and writing the formulas for ionic versus covalent compounds. And so knowing the difference between the two is very important. And so we're going to learn, we're going to practice that skill momentarily. All right, so before we go ahead and look at comparing ionic versus molecular compounds, we need to go through just a couple of details here for molecular compounds. Some of their properties. So often molecular compounds exist as gases. If you look at the periodic table, go to that here. These are all nonmetals, and most of them are gases at room temperature. If you notice the lettering here, if it's in red, it's a gas at room temperature. Of course, all of these are referred to as noble gases. They're gases at room temperature: fluorine, oxygen, nitrogen, chlorine. So a lot of them are gases at room temperature. That's one property of nonmetals. They have low boiling points, okay, and low melting points as well. And so we do a common experiment in high school where we compare the melting point of sodium chloride versus sucrose. So, you know, sodium chloride is table salt, and it will not melt at the temperature of a Bunsen burner, which is around 1200 degrees Fahrenheit. But sucrose, which is table sugar, will melt, and sucrose, the formula for sucrose is C6H12O6. Well, those elements are all nonmetals. So sucrose is a molecular compound. It has a low melting point, okay? You're able to melt it, and that's actually, when you do melt sugar, you end up making caramel. So it's a very pleasantly smelling chemical whenever it's melted. So looking at our example here in your textbook, here they're looking at trying to predict whether a compound is ionic or molecular. And so here, their first compound, they give you Ki. And so the way you have to do this, there's a systematic process here. You have to basically look up each element on the periodic table to figure out if you have two nonmetals or a metal and a nonmetal. So here, Ki, K is potassium. If I look up potassium here, well, that's a metal. Okay, so potassium's a metal, and then iodine over here is a nonmetal. So let me switch over here just a second to a periodic table that's color-coded for you. So here's a periodic table that's color-coded based off of whether the element is a metal, a nonmetal, or a metalloid. So metals are shown in red here, nonmetals are shown in blue, and then metalloids are shown in yellow. So again, looking at potassium, it's a metal. Iodine, it's a nonmetal. So if I have a metal and a nonmetal, the compound is going to be an ionic compound. All right, next one, H2O2. So I need to look up hydrogen and oxygen. So, all right. So hydrogen is a nonmetal, oxygen is a nonmetal. So because you have two nonmetals, that compound would be a molecular compound. Okay. So next one, chloroform here, CHCl3. So carbon, hydrogen, and chlorine, I need to look those elements up. Carbon is a nonmetal, hydrogen is a nonmetal, and chlorine is a nonmetal. So that compound would also be molecular. Part D, you have lithium, you have carbon, and you have oxygen. So looking up on my periodic table, lithium is a metal, oxygen is a nonmetal, and then what was the other one? Carbon is a nonmetal too. So because you have one metal and then two nonmetals, it's going to be an ionic compound. Okay, so going through this process, when you're given a compound, you're going to have to first figure out, is the compound ionic or molecular? And the reason for that, again, because we have different series of rules, okay, that we have to be familiar with. And the only way we can do that is by first being able to differentiate between an ionic versus a molecular compound. All right, so we're going to continue learning how to name inorganic compounds using a systematic approach. So nomenclature is basically collections of rules for naming things. It's a very systematic process. Compounds can be identified with both their formula and their name. If we learn how to name the following inorganic compounds, or we will, ionic and molecular, binary compounds. A binary compound is composed of two elements.
Okay, and then we're also going to talk about ionic compounds containing polyatomic ions. We talked about that a little bit on Wednesday. And then finally, we'll learn how to name acids. Okay, so when we talk about, we've already talked about naming ionic compounds. We're going to sort of review that. And then naming compounds with polyatomic ions. We sort of talked about that on Wednesday as well. And then we'll jump into naming molecular compounds and acids. So when we're naming ionic compounds, we name the cation first, followed by the name of the anion. If you have just a monatomic cation, it's just the name of the element. So, for example, monatomic cation would be like calcium plus 2. So it would just be called a calcium ion. But if you have if it's a binary compound, you have to the cation's name is just going to be the element's name, and then the anion's name is going to be you have to trim off the N, a couple letters off the N, and replace it by the suffix IDE. And so we did that. We did some of these on Wednesday night. And then a polyatomic ion is just going to be the given name of the ion. So here's a table from a different book. And so we were talking about these ions, how, if it's a cation, it's just going to be its element name, calcium. But if it's an anion, an anion, of course, has a negative charge. Chlorine becomes chloride. You're changing the suffix, that IDE part. Okay. Fluorine becomes fluoride. Now, you notice we have some other compounds here that are polyatomic ions. And I gave you, there is a list on your PowerPoint earlier with all the polyatomic ions that you have to know, have to memorize, that I told you about. And so you're going to have to memorize the name, the formula, and the charge. And so here's a table of this, but I just wanted to show you because to get you into the habit of changing the ending of an anion to IDE. That's a really important. Some students forget to do that when they're naming compounds. So when we look at the name of some ionic compounds in its formula, so NaCl, first of all, looking at the formula, it's an ionic compound because sodium is metal, chlorine is a nonmetal. The sodium is a cation. It's always written, the cation is always written first in a formula, a chemical formula. So Na is sodium, Cl is chlorine, but chlorine becomes chloride, so its name is sodium chloride. KBr, so K is potassium. All right, so I know I'm going a little fast. So let me get the periodic table out here so you guys can follow along, and we'll go through this in the process. Okay, KBr. So let's go to the periodic table here. K is the cation. K stands for potassium, so it would be potassium. And then Br is bromine. And so I'm going to change the ending bromine to bromide. So this would be, KBr would be potassium bromide. Okay, Cai2, so Ca is calcium. I is iodine. Iodine becomes iodide. So the name would be calcium iodide. CSF. CS is cesium. F is fluorine. Fluorine becomes fluoride. Cesium fluoride. Okay, so LiCl. Li is lithium. Cl is chlorine. Chlorine becomes chloride, so LiCl would be lithium chloride. Na2O. Na is sodium. O is oxygen. Oxygen becomes oxide, so the name would be sodium oxide. CdS, so Cd is cadmium. S is sulfur. Sulfur becomes sulfide. This is cadmium sulfide. Mg3N2. Mg is magnesium. N is nitrogen. Nitrogen becomes nitride. So this is called magnesium nitride. Ca3P2. So Ca is calcium. P is phosphorus. Phosphorus becomes phosphide. So calcium phosphide.
Al4C3. Al is aluminum. C is carbon. Carbon becomes carbide. So aluminum carbide is the name for that. All right, when we're naming compounds that have polyatomic ions, it's pretty simple. You just write the polyatomic ion name. So here we have KC2H3O2. So C2H3O2 is acetate. Okay, so its name here would be just K is potassium, and C2H3O2 is acetate, so potassium acetate. The next one, NH4Cl. So I guess the hard part about this too, when you're looking at a compound, you notice they have 3 or more elements. So you know it has a polyatomic ion. And I guess what's hard probably the most for students is to be able to figure out which elements form the polyatomic ion. So that's why it's critical that you memorize your polyatomic ions so that you can you can look at them and you can sort of figure out where they are in the compound, okay, and how they're grouped together. So NH4 is a polyatomic ion called the ammonium ion. Okay, so the name for this compound would be ammonium. Chlorine becomes chloride, so ammonium chloride. NaHCO3, so again, you're having to figure out what part of the elements are together as a polyatomic ion, and so HCO3 is bicarbonate. So you're having to figure that out first, and then you have to, of course, the cation's names. Na is going to be sodium, HCO3 is bicarbonate, so its name is sodium bicarbonate. CaSO4, Ca is calcium. SO4 is a polyatomic ion, it's called sulfate. So this is calcium sulfate would be the name, calcium sulfate. Here we have aluminum, and we have CO3 is called carbonate. So here we have the compound aluminum carbonate. Finally, we have magnesium, and then we have PO4. It's called phosphate. So this formula is called magnesium phosphate.